Let's review your notes 3-5. This is in zeros of polynomial functions. We're going to review multiplicity. So multiplicity is the number of times a zero repeats. And if you remember from previous lessons, we've mentioned that a zero, x-intercept, root, solution, pretty much the same name for the same thing, different contexts. If we have an odd number, so an odd repeats, graph is going to cross the x-axis. If it repeats an even number of times, the graph has a turning point on the x-axis, so we call it a touch and turn. We abbreviate it as T and T, and what the graph is going to do is it's going to kind of like bump and bounce off the x-axis. And this is going to start making a little bit more sense as we see some examples. So here's two examples. These functions look very similar, but let's break them down. So to get at those zeros, the solutions, the x-intercepts, the roots, we would need to factor. So here I've just actually expanded this one. And then we can go ahead and use our zero product property and solve for x. Now notice this is we have two zeros here, x equals 4 and x equals 4. Because you see 4 appear twice, we'd say it has a multiplicity of 2. 2 is an even number, which means wherever x equals 4 on the graph, your graph is going to come down, touch the x-axis at x equals 4, and it's going to turn around and go back up. Now we also know from looking at this from our previous studies, we have a degree of 2. This is even. I don't see a negative out front. This is positive. This is even positive. So our end behavior is up, up. And I have this x-intercept at 4. So my graph comes down. It does a touch and turn. It touches the x-axis, turns around, and goes back up. Now when we look over here at x squared minus 4, this is difference of squares. Here it is factored. Use my zero product property. I get x equals -2, x equals a +2. Now notice these are two different answers. So -2 appears once, so we say it has a multiplicity of 1. X equals 2 appears once, it has a multiplicity of 1. Now 1 is an odd number, so if it's an odd number, it crosses the x-axis. My end behavior, just like with the first one we looked at, this is going to be even positive, which means my end behavior is up and up. And so here it is. So now I have these two x-intercepts, and because I noticed that my multiplicity is 1, it's odd, my graph has to go through those x values. So it is crossing the x-axis and coming back up. We look here, the quantity x minus 1 raised to the 4th power. Now, if you expand that, you see you're getting the same factors 4 times. So when you solve, you're going to get x equals 1. That is going to appear 4 times. Factor of 4 because it appears 4 times. And because 4 is an even number, we know it's going to touch and turn. So at x equals 1, my graph is going to come down and it's going to bounce off the x-axis. My end behavior here is also even positive. The degree of the function is 4. I'm not seeing a negative sign. This is positive. It's up and up. Here's the graph. It comes down, does a touch and turn, bounces right off the x-axis. Now also notice here we have a degree of 4. You get 4 zeros. Up here, we saw you have a degree of 2, you get 2 zeros. If you have a degree of 3, you're going to have 3 zeros. A degree of 5 will have 5 zeros. A degree of 6 will have 6 zeros, etc., etc. That does not necessarily mean, however, that the zeros are the same as the x-intercepts, because if we have imaginary solutions, our zeros have complex numbers in them, the graph won't touch the x-axis. And we're going to see some of those later on in our studies. Let's take a look. Let's do a few problems. So here we go. We're going to go ahead and identify the multiplicity and graph these. So right off the bat, I don't even need to use my zero product property. You can literally see your zeros just by looking at this. So here, if you just have an x, you'd set it equal to 0 using your product property to solve it. Well, there's nothing else to solve. Here, x minus 4 equals 0. Again, this is going to be x equals 4. 4 minus 4 is 0. Take this number, change the sign. So I have x equals 4. And here, x equals negative 3. Now notice, none of these numbers repeat. So these all have a multiplicity of 1. So this is my multiplicity. I'm just going to abbreviate multiplicity. And because 1 is odd, my graph will cross the x-axis at each of these x values. Now let's talk degree, because I need to know my end behavior. I'm in factored form, and we know that when we pull the degree of a polynomial, it needs to be in standard form, because we're looking at the highest degree. But we don't necessarily have to go ahead and multiply this out. We can think about our properties of exponents. So if you think about it, this x has an exponent of 1. X minus 4 has an exponent of 1. And x plus 3 has an exponent of 1. When you multiply, and you're multiplying the same base, notice I have all x's here. Keep the base, you add the exponents. So you are going to just add the exponents. 1 plus 1 plus 1 equals 3. This is a degree of 3. Also notice, we came out with 3 zeros. Okay, that is related to your degree. So now I know it's a degree of 3. 3 is an odd number. I don't have any negatives up front, so my end behavior is odd positive, which means my graph goes down and up. So let's just sketch a really quick graph. Okay, so I'm going to put my zeros in. I have 0. I have a positive 4. We'll call that 4, and we'll call this one a negative 3. And my behavior goes down and up. So now I'm starting at my end behavior, and I know at each of these x values, my graph goes through the x-axis. So here I go. We're going to go up. We cross the x-axis. That's an odd multiplicity. Come down. We got to cross the x-axis again. And then we cross it again. And there's a rough sketch of our graph. Let's do another. We have x to the 4th minus 81. So I have a 4th degree polynomial. I can expect to get out 4 zeros. So let's factor this. This is difference of squares. So this is going to factor as, we're just going to make our 2 sets of parentheses. We got 1 plus, 1 minus. We'll set it equal to 0 because we know we have to solve. Okay, square root of x to the 4th is x squared. Square root of 81 is 9. Now I could factor this one again. This is another difference of squares, but I'm just going to go ahead. I'll use my square root property to solve. So let's set each factor equal to 0. zero product property. And now let's solve. I'm going to subtract the 9. I get x squared equals -9. To get rid of this square, I need to take the square root of both sides. Don't forget when you do that, you need to do plus minus. I get plus minus the square root of -9. Now, whenever you have a negative number underneath the radical, that means you have a complex solution. So that's going to come out as the imaginary unit I. So this breaks down to x equals plus or minus the square root of 9 is 3. The square root of -1 is I. So here's 2 of my 4 solutions. X equals positive 3i and x equals a negative 3i. Now let's take a look at this guy. If I'm gonna add 9 to both sides, I get x squared equals 9. Take the square root of both sides. X equals plus or minus the square root of 9. X equals plus or minus 3. So that means I also have x equals a positive 3. X equals a negative 3. Okay, here's my 4 solutions. 4th degree polynomial, 4 solutions. These, whenever we have complex solutions, means the graph isn't touching the x-axis. These are what we're going to be concerned about right now. So notice 3 only appears once, -3 appears once. This is multiplicity of 1. And because 1 is odd, it's going to cross the x-axis at these points. So here we go. Let's squeeze it in right here. My end behavior, this is even positive, so this is up and up. I have an x-intercept at -3 and another one at +3. So here I go. I have to come down. I have to cross the x-axis at x equals -3. I have to cross the x-axis at +3. So that means I need to come back up and go up through.